Oh, hey guys, what's up? Eddie Aho here with KissAnalog.com. Today is a Tech Talk day, and what I thought I'd do is tell you a story about one of the designs I did and how it didn't turn out. It turned out awesome, but it didn't turn out the way we thought it was going to turn out. It went down, kind of took a left turn and went the right way, but yeah, had to kind of change some minds. Change minds in an industry, actually. So, pretty cool story. Now, this will also kind of shed light on kind of the nonsense of adding a ground rod to get lower noise. You know, some of these audiophile people who are really worried about the green wire, that ground system, you know, improving the sound stage and all that kind of stuff. Okay. So sometimes there's a whole industry that has a belief system and people just buy into it. And I got this job with a big electrical company, which a lot of you guys know. Anyway, at this company, we work close with the marketing and sales people. So we would get a project and we would have a budget and we would put together basically a proposal, a design proposal, saying this is how we think we're going to accomplish that. This is what the board costs, the parts cost, all this stuff, and then we'd have monthly meetings, and we'd have even other meetings that we'd get together with to discuss progress and all that kind of stuff. All right. So this project, I was going to do a surge protection for a copy machine. Okay. Now, copy machines, when they go down, they set a company behind, and there's a lot of money wrapped up into that. And if you have too many copy machines, then that's expensive too. You have too few. So there's really a lot of study that goes into this, and the downtime is a big deal. So what they really want is filtered power, and they want surge protection to try to protect that copy machine. Okay. So this company, one of the marketing guys or sales guys got a customer, and the customer in our region sells a lot of copy machines or leases them or whatever. So he wants to guarantee that, hey, these things are filtered better than everybody else's. And there's some really good competition out there from small companies who just focused on making a power strip for these kind of machines, and they would affix them to the back of the copy machine somehow. They would take the power cord from the copy machine, plug it in this power strip, that have some kind of restraining strap to lock that thing in there. So since you're going to guarantee this thing wasn't going to go down, you wanted to make sure that somebody didn't come along, plug a fax machine or something else into that because they needed some power, and then the copy machine got plugged into something else, and you know, that kind of thing. So they would usually put these things in the back of the machine, Velcro them or whatever, something like that, and kind of out of sight and protect the machine. Okay, so I got this job, and they asked me if I could design a filter better than our competitors so we could really crush them, because we're a big company. Hey, why don't we put the money together, design something that just kills all the competition? So I'm like, you bet I can do that. But you know, I had a budget. Also couldn't be a lot more expensive. Just because we're a big company, we couldn't say, hey, our unit's so much better, so it's worth twice as much. It's a very competitive market. So I was in the lab, and well, here, now let me tell you what part of the requirement was. What these techs that go out in the field that, you know, repair these copy machines, what they found was that, you know, they would investigate, and they would take their multimeter and measure the power at the socket to make sure it's clean, to see if it was, you know, wasn't lower voltage than what should have been there or something like that. Maybe the drop in the wall was so long to where the breaker panel was, maybe the voltage had dropped. And so they're like, well, you know, so they were trying to investigate. And what they found in the cases where the copy machines had the biggest problem was what they thought is, well, when I measure the voltage between neutral and hot, I measure 120, 117. Okay, that's pretty good. But when they measure it from, say, hot to that ground connection, same thing. Okay, I mean, roughly. But then when they measure neutral to that ground, they would see 1 volt, maybe half a volt, usually over half a volt. So it got to become a belief and a part of the belief system and for the culture of these people, and not just for this one company, but amongst the industry. People were believing that, hey, when you measure over half a volt difference, you're going to have problems with that copy machine. It's going to go down. And you know, whenever they had ones go down, they would usually measure something like that, a volt, half a volt. So that became a real belief system. So part of my requirement was, hey, let's filter that so that we don't have that voltage, you know, that we're going to be lower than everybody else. Well, as I started going to design and we're doing the marketing survey, which, you know, you go obtain your competitors' units and you take them apart. You look at them, you look to see what magic they're doing to do what they do so you can do something better. You're not copying them, right? But you got it. You don't want to reinvent the wheel either. So it's marketing research, right? So in doing that, we did find a couple competitors who were doing things that weren't correct by UL, the safety agency standards, but they had a UL marking. When you find that as a consumer or a competitor, you turn them into the UL office, say, hey, this is unsafe, but they have a UL marking, so what's up with that? And then UL would investigate and say, you're right. So that's what we did. And they came back and they said, you're right. But what they said was somebody else had already turned them in. So they had already made a change to that product. Well, we got a newer product and we looked at that and we saw what they did. And we said, that's not correct. But what happened was UL had actually kind of given them the nod of approval for this design change. And then they realized, oh, shoot, yeah, that's not good. So then UL was worried about being sued. And so they didn't know how to handle it. And they're working with the company to try to help them change it without having a big financial problem, because it was kind of unfair that they kind of got led astray thinking that this was a fix. And what they did essentially was that when you test per the standard, it would pass. But what it was doing is it was basically doing a delay, not on purpose to, try to sneak by, but just by happenstance, it would pass UL testing. What they would do is they would bond a neutral to ground together. We know that's not right, right? So that was their first design. That was a no-no. So that got a hand slap. So they had to change their design. So now what they did is they took an aluminum electric capacitor and they put it across neutral to ground. Well, that's not good either, guys. Whenever you put a capacitor from neutral to ground, hot to ground, it has to be a safety rated capacitor. They call them X or Y caps, right? The Y caps are the ones that go to ground. X caps go from line to neutral. So they had to use an aluminum electric capacitor, and that is not a safety cap. In no way, no shape, no form. That is just not a safe cap. It's probably one of the most unsafe capacitors they could have put there. Not only that, the voltage rating wasn't high enough. Well, it was rated for 16 volts or something like that. But hey, there's not supposed to be any voltage between there, right? Sometimes there's a volt. So voltage rating is fine. But that's not the deal. There's surge voltages and stuff like that on your power lines, right? And so maybe they go up to a few hundred volts sometimes. No one ever notices. Nothing's ever damaged. But a 16 volt cap would be. Aluminum electrolytic. Did I mention that? Anyway, so all right, so I got going on my design, and I thought I put together a good design, multiple poles and all that kind of stuff, common mode chokes, I think a couple sets of them, differential mode inductors, and part of the thing with an EMI filter that's just as important as what the schematic shows in components is the quality of those components. Just as important. Another thing equally important, so let's say it's in 3 parts. First, you have to have a good schematic, a good design. Second, good parts. Third, nice layout. Those three things go hand in hand. You mess up any one of those three things, it'll ruin your filter, okay? So I'm in there testing and I'm trying to, you know, do the best thing I can do, right? And then I realized, and the package, as far as the package go, the plug strip, it wanted to be something around this size, 4 to 6 terminals. Fax machines, other things would plug into this. Because you know, in your office area, you might have an electric stapler. You might have different things that plug in your office machine area. So at least a phone, probably a fax machine, and you know, and your copy machine, right? So you want at least 4 receptacles. So I'm kind of working with the thing. I'm like, okay, I can fit a nice design in this. And then it hit me as I'm testing. And I'm like, it's one of those things like, the light just goes off. And I'm like, oh man. Somebody tells you a story and they lead you down the road and you buy into it, and then all of a sudden they give you the punchline and you're like, oh man, I should have saw that coming. And it was one of those kind of things. And I just realized the whole industry had it wrong. It had nothing to do with that 1 volt, half a volt from neutral ground. It had zero to do with that. Well, let's not say zero. For one thing, why would you have that voltage difference? Well, if you're really close to the circuit breaker panel that your power line came off, your voltage line that they ran, you know, down to, let's say, your office area. Maybe they run down the hallway and then they go to this little office area that's in between all the cubes, all the offices, and they set up the copy machine there. So you might be kind of far away from the breaker, right? Well, the current returning back on the neutral is going to be whatever it is. It's going to be a little bit more significant because every cube, every office adds to that current going back, right? So the current across that Romex wire in the wall, it's going to have some voltage drop. It's half a volt, 1 volt. Oh, wait, hold it. That's what we've measured there. Oh, wait, hold it. That's so essentially what they're saying is you have to move your copy machines close to your breaker panel or run a lot bigger wire to it, right? Well, it might have been a sign of other things that was actually causing it. So it might have been a symptom they thought was something to look for. But what they thought that symptom was doing was totally wrong. It might have been showing that they're far enough away from the circuit breaker that there's a bunch of other things between them and that, right? So the power that they're getting is downstream. It's kind of like being downstream of a bunch of other people bathing in a stream, right? You're going to get all their dirty water, right? So even though it might not be the same color water is down there, you know, I mean, it's dirty, right? So it was actually the power between line and neutral. It's just dirty power. It has nothing to do, and that maybe because it is dirty power, they would see the difference in voltage drop there. But you can clean that power and still have that voltage drop because you're still going to have that voltage drop because the neutral is going to drop so much voltage. That's just going to happen. So I was sitting there that night going, oh man, I'm going to have to put some slides together. I'm going to have to explain that the whole thing we're trying to achieve is not achievable. And the way other companies do it has not been up to UL standards. And so what do we actually do? So it just hit me that, okay, so what it is it's just noise. I just reevaluated the whole thing. I'm like, it's just noise, line to neutral. So you really do want a good filter. But now I got to tell the story. So I did some research and I found someone who does a lot of EMI testing, a local lab, I mean in the region, not in, like I'm in Utah. It wasn't in Utah, but it was in the region. And they had all these papers about common noise and being an issue with copy machines, printers, things like that. I'm like, yeah, these guys are onto it. That's what it is. It's a noise, and it might be common mode is you might get a wave shape on the line. That same wave shape's on the neutral, right? And that's referenced, so if you reference your scope to the green wire and you touch the other two, you'll see the same waveform. That's common mode. It's common to both conductors reference to your earth ground, your chassis ground. I hate to say earth ground. Your green wire has nothing to do with ground stick, all that kind of stuff, all that nonsense. It just has to do with that third wire that your EMI filters are all having white caps go to, okay? So essentially, with third wire prongs, we're all adding noise into that ground system. It's not a nice, pretty place. It's not, ground rods aren't going to clean it up. That's not a thing. So when all these machines are putting noise into that ground wire, some of them are, it's circulating between the different machines to some degree, because the EMI filters, even when you turn off the power cord, a lot of them are still connected. So you got currents just circulating through these things, okay? So I thought, you know, what we could really do, because now how can we differentiate ourselves? First of all, we have to sell that story. Second of all, we have to differentiate ourselves. How do we do that? Well, we just have a better filter. We have more orders. We can show the filter, the roll off and stuff. And, you know, that's kind of high tech, and that's going to be a harder story to tell, especially when you try to, first of all, tell everybody's wrong. Oh, you're right, and this is the way it is. Well, the CEO, really great guy, he would come by every so often, and I was working late one night. He just came down to see who was working late. Came in, he knew I was there probably. So he came in to just chat with me to see how things are going. And I said, man, I kind of told him the story, so I'm going to put it together so that I can sell it to the marketing guys and all that kind of stuff, and give them something that they can sell, you know, give them a sellable story. So I told him, I said, you know, what would really make our thing different than everybody else's is if I could do another stage of filtering. So I'm going to filter all the power, then people are going to plug fax machines, other things that create noise too, and then that's going to go right into our copy machine. So I said, if I could do another stage so that the receptacle that the copy machine goes into is isolated, you know, EMI isolated by another stage, then we can give a special extra stage of filtering just for that copy machine. I go, that's something no one's done. And he's like, I love it. And I said, the problem is I got to sell this to our team, because I need more budget to buy those extra parts, because I can't just put them in the schematics, say we did it without buying good quality parts. And he's like, how much more? And you know, it was a couple bucks or something. He's like, do it. Well, I was already real close, or maybe even over budget a little bit, because I was really trying to do a good job. And he's like, do it. It's a no-brainer. Do it. So put together the story. Marketing guy took one of our products out in the field, one of the early ones, demo, took it out to a show, and he kind of got blasted out of the water, because they were already sending marketing literature out to people, and so the competition had time to try to get ready for that show, so they didn't get, you know, tagged. So what they did was they acquired some of the products, and they got one of our early products. They tested it, and maybe our marketing guys knew they were doing all this. I didn't know about it until after it was done. But anyway, they came back. They said these three have varying goodnesses on how good they are in comparison to each other. This one company, the one that had the biggest market share, was the best. And then us, we were over here. We had a whole different, we tested pretty good over here, but we tested better in other ways. Common mode noise and stuff, we were all better, way better. Plus we had that extra socket. And so we were over here. We were kind of like the weird guys. And so marketing guy came back, the sales guy came back and said, man, I don't know how this is going to go over, because we kind of got, you know, we kind of got eaten up at the show, because everybody's like, oh, well, these three guys, they're all doing the same thing. What are you guys doing? You guys doing something else? So I was like, oh, geez, you know, I mean, is too technical for sales guys and marketing guys to sell on the show, and the white paper I put together wasn't good enough either. And so I thought, man, you know, I wasn't sure what to do. I did some research, went to that one company that was talking about all this stuff. I'm like, man, you know, from what that company is saying, we're doing everything right. And then I got the report from the sales marketing guy. So he sent that to me later the same day. It was kind of late in the evening. Sent it over to me, and I was reading through it and everything. And I'm like, I'm sure we're right, but man, it just doesn't look good. Then I saw the name of the third party test company that put together this report. Guess what? It turned out to be the same company by happenstance that I was researching. One of them. I mean, I researched a bunch of companies writing white papers and that, but this company had a lot of white papers, and it was the same company that did the test. And I was like, what the heck? I mean, they're saying the same stuff I'm saying, and now for this test, compare these units, they're changing their story, and they're saying this is the better method, and these guys are this is how they stack up. I'm like, what the heck? And I knew a guy who had worked for one of our competitors, and I can't remember how I found him, or he found me, I think. And anyway, we had shared some knowledge about lightning and how we put together our specs and stuff. And he told me about how, all right, so I'll just tell you. So he told me about how when they came up with their surge rating, that he was trying to set them straight, and they said, maybe we don't need you for this part. Thank you very much for the design. Thank you. And I can tell you, I would tease our marketing guys too. I'd say, where'd you get your marketing calculator? I need to get one of those so I know what you guys are talking about when I come to these meetings. But anyway, it was kind of an industry thing. When you look on a box and it says 100,000 joules of protection or 100,000 amps of surge current, things like that, they add up the line to neutral, the line to ground, neutral to ground. If there's telephone protection, which there usually is, Ethernet protection, they add up all the joules, all the MOVs, all the surge currents, put them all together, even though they're all different functions. They add them all up and say, yeah, you got this much milliamps of surge current. Well, you kind of do if all those things are being hit by lightning at the same time, but it's misleading, right? Anyway, he was telling me that story. So I contacted him again. I said, man, yeah, I'm trying to figure out like what the deal is with this lab, and I'm waiting for an email back from him. And he says, oh, that lab? He goes, you know who that guy, before he opened up that lab, you know who he worked for? He was the chief engineer at that company that's topping the market over there. So he's still friends with all the guys because he was one of them. And so he just went off to start his own testing company. I'm like, oh, okay. So I went to our marketing sales guys, and I downloaded the white papers that they had, and I yellow highlighted things. And I said, look, we correlate. We're consistent with that third-party lab who gave that report. And from their white papers, you know, they're agreeing with what we're saying. They're agreeing with our story. We don't know why the report was totally lopsided. We didn't point out who the guy worked for and all that stuff. But I did tell the sales guy and the marketing guys that. So if they're out in the field talking to people, they could let that little piece of information out too. So I just thought this would be an interesting story for Tech Talk, because it kind of tells you as an engineer, when you're designing something, maybe if you're being led by the nose into a design, that maybe you have to stand back and go, wait, is that the right way to approach this? Does this make sense? And maybe I would have caught myself a few weeks earlier, and you know, anyway, things all worked out. But it was just kind of funny how I was in the lab one night and I went, what the heck? Like the lights just turned on. So yeah, sometimes even if the whole industry is saying something like that, you know, get a ground box full of dirt, put some wires into it for your audio system, and it'll make it sound better. Maybe sometimes you have to step back and think, really? Is this really a thing? You know, the ground wire just does not matter, guys. It's for safety ground in case something shorts. The line shorts to like a motor that's inside there, the fuse, you know, something, a wire's frayed. If something shorts to the housing, which is supposed to be same voltage potential for all of us to be safe, if that happens, it's going to trip that breaker, and they give you that green wire, that third wire, to do that. It stopped a bunch of house fires. It stopped a bunch of fires since they did that and all that. But guess what, guys? Before the 50s, they had some pretty good audio equipment, right? I have some tube amplifiers. Macintosh made some pretty good amplifiers. They didn't have a green wire. They didn't have ground rods. So, yeah. Okay. All right. Hope you like this. 2 thumbs up to my patrons, my members of my channel, to Danny being a Ting member. You can become a member. Patreon links down below. You can buy me a cup of coffee or beer for a rant, you know, Friday, Saturday night, Sunday night. I don't know. Anyway, thanks for watching. Free way to support the channel is just to like the video, share, you know, subscribe if you haven't done so. That would mean a lot. Yeah, it's a slow growth these days in YouTube. If you guys, you know, the money, all that kind of stuff, Amazon, all that stuff, it's kind of flatlined. It's changed from the old days. So for channels like this that are trying to make it, yeah, it's literally, I've already spent twice as much time as other channels back in the day. And anyway, it's way harder these days. So hope you like this video. Thanks for tuning in, and I appreciate you. Oh, and comment down below if you like this. One of the things I want to do on these Tech Talks is show you new technology and stuff like that. I just thought, you know, some people have been asking me to tell a little bit more stories about my designs, my past. So I just thought I'd kind of mix them in with some tech, you know, some tidbits. Kind of, this one I think kind of tells you as a professional engineer, whatever, you know, as an engineer in your profession, how to maybe handle certain things and how to think about your designs and things like that. So, and also the whole neutral to ground thing and the meaning between those things. So hopefully that was enough tech, interesting talk, and we will see you next time. Thanks, guys.